parallelograms. Our objective is that I can find all the angles of a parallelogram and find its area. So, when naming a parallelogram, we name the corners, the vertices of a parallelogram, and we use capital letters to do it. Then we can also name each of the four angles after its letter. So this guy right here, this angle is angle A. This one is angle B, and so forth. There are some special things about each angle of the parallelogram. The two angles that are across from each other are the same. So angle A is equal to angle C, and angle C is equal to angle A. Pretty cool. Also, that means that angle D and B are the same. So they're equal to each other. And angle B is equal to angle D. And two angles that are side by side are supplementary. That means that they add up to 180 degrees. So if I look at angle D and angle C here, and I know that angle D, so angle D plus angle C is equal to 180 degrees. That's what it means to be supplementary. So if I know one of the angles, let's say that angle D is 50 degrees, that means that I now can make a new equation, and that equation will be 50 degrees plus angle C will be equal to 180 degrees. Then I could subtract 50 degrees from both sides, and I'll get angle C must be 130 degrees. And in fact, I think that's what we're going to do next. So if two angles are next to each other, they are supplementary. They add up to 180 degrees. And if two angles are across from each other, that means that they are the same. So let's try one together. In this parallelogram, ABCD, the measure of angle A is 60 degrees. What is the measure of angle C? Well, angle A and angle C are across from each other. That means that they're the same. So angle C is 60 degrees. Pretty cut and dry, pretty simple. Go ahead and try this one on your own. Pause the video, and I'll see you in a second. Okay, now that you've tried it on your own, let's try it together. So, if we know that the angle A is 60 degrees, and we want to know angle B, we remember that two angles that are next to each other are supplementary. That means that they add up to 180 degrees. So, 60 degrees plus angle B is equal to 180 degrees. I'm going to subtract 60 degrees from both sides. And we'll find out that B is 120 degrees. Okay. Next, we want to talk about the area of a parallelogram. It changes with the angle. So what I did is I took a square here and I just scooted it over. I skewed it. So I pushed, right? I took the wall of the square and I pushed it in, and now it's all bent. But we calculate the area the same way. The area for any parallelogram is the base times the height. So the height used to be the whole distance here. That used to be the height. And so the area actually went down. It's now shorter. The parallelogram is shorter once I squished it and then decreased this angle right here. So it made the area smaller, which means the total area is smaller. So let's try and find the area of this parallelogram. Okay, all we need is the base and the height. The area of a parallelogram is the base times the height, which means we don't need to know this side length right here. We're just going to ignore it. It's there to trick us. So the area of this parallelogram, I'll call A. The base is 6 centimeters times the height, which is 5 centimeters. 6 times 5 is 30. Centimeters times centimeters are centimeters squared. So the area is 30 centimeters squared. Go ahead and pause the video and try this one out on your own. Okay, now that you've tried it on your own, let's do it together. So I need to know the base and the height, and I don't need to know this side length right there. We're just going to ignore it. So the area is the base times the height. I know the base is 8 inches, and I know that the height is 5 inches. 8 times 5 is 40 inches squared. And that's my answer, 40 inches squared. Thanks for watching. I'll see you in the next video.